Hi everyone, welcome back to chemistry. I lied in the last video. I said I was going to go over 3.4 energy at the very end of the video, but I forgot. So I'm making a new video because I don't know how to edit videos. So in this video, we will go over 3.4 energy, and it's going to be a really short one, I promise. So let me go ahead and set my timer so I know how long I'm talking to you. All right, so I just want to go over some parts of this section, and then we'll go over it in depth more in the future. But I just wanted to let you know about units of energy. So units of energy. So remember when we talked about the SI units for different types of measurements we can take? We didn't mention energy. So I wanted to tell you what it is. The SI unit of energy, you'll also sometimes see this as described as work, is the joule. And we use a capital J to symbolize that. So you pronounce it joule like a jewelry or something, and it's a small amount of energy. So scientists actually often use kilojoules, which is 1,000 joules. And that should sort of make sense because remember, 1 kilometer is 1,000 meters. 1 kilogram is 1,000 grams. 1 kilojoule is 1,000 joules. Okay. So that's just a side note there. And there's also another unit of energy called the calorie. Another unit of energy, the calorie. And we know about that from foods. Different foods that we eat are often talked about on wrappers and stuff that we eat. So the calorie is actually from the Latin caloric, which means heat. So it's defined as the amount of energy or heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. We don't really need to think about that right now, but it's just something that's kind of interesting. And scientists will also use kilocalories, right? Just like they'll often use kilojoules, and that just equals 1,000 calories. So 1 kcal is 1,000 cals. Okay. All right, that's all I wanted to tell you about units of energy. But I did want to remind you that, so anytime you have, energy, you can use that in dimensional analysis problems, right? You can create a conversion factor from that. So remember, if we have 1 kilojoule, sorry, that should be a capital J. 1 kilojoule equals 1,000 joules. We can make that into conversion factors. So we can say 1 kilojoules on top, 1,000 joules is on the bottom. Or we can say 1,000 joules is on top and 1 kilojoule is on the bottom. Okay, so just something to note that you can make conversion factors from these energy units. Okay, so let's just try one real quick example, how to use these in equations. So let's do this. A defibrillator, and I'm looking at the example in your book, which is on page 75. Let's write that down for you. So a defibrillator gives a high energy shock of 360 joules. What is the quantity of energy in calories? What is the quantity of energy in calories? Okay, so to do this problem, you need to be given, and you will be given this on a test, you need to be given the conversion factor that 1 calorie equals 4.184 joules, and they specify that this is exact. Okay, so this is an exact number. This isn't a measured value. All right, so you don't have to worry about sig figs for this specific one, for this specific conversion factor here. Okay, so let's try to solve this. So what do we have, and what information do we have, and what are we trying to get to? We want to know if we have 360 joules, what is that in calories? So this is what we are given, and this is what we need. Okay, we want to have that number expressed in calories. So let's go ahead and set up our dimensional analysis problem. Again, we're going to start with what we're given, 360 joules. We'll set it up like this time. Okay, so what goes in the top of our fraction here for this step? What are we going to put there? Calories is going to go up there, 1 calorie. And on the bottom, we're going to have 1.84 joules. Remember, because we want to cancel out these joules so that we're left with calories, which is what we need, right? Okay, so remember that I will give you this conversion factor on an exam. You do not need to memorize that. So let's carry out our calculations. We got 360 times 1, which is just 360. And then we're going to divide that by 4.184. Whoops. 360 divided by 4.184. And that's going to give us 86.04206 ... calories. Okay. And now it's a matter of making sure that we have our significant figures correct. So how many sig figs are in this? There's actually just 2. There's just 2. And the reason for that is that we don't see a decimal point here. Okay, so that, we don't see one here. So that 0 right here is actually not significant. If there was a decimal point somewhere in this number, then that 0 would be significant, but there isn't a decimal point, so it's actually not. So this actually has, let's go green here, this actually has 2 sig figs. Okay, we were told that this one is exact, so we don't need to worry about that. So our final answer should have how many sig figs? Yeah, it should have 2. So we want to round to this number. So that's going to be 86 calories. That's our final answer. Okay, let's double check that. Yeah, we got that right. All right, and now that has like 2 sig figs, right? And I'll just write that in there for you. Okay, so I promised this would be a short video, so we're all done. If you have any questions, let me know. I just wanted to make sure that you know some of the units for energy and that you can use them in problem solving. All right, have a good rest of your day.